example. Today we are going to discuss about the pH of strong base. We know that in the pH scale 0 to 14 value present. In the 0 to 7 this is the acid, 7 to 14 this is the base value and 7 is the neutral value. For this pH of strong base, first of all base, that means in the base presence of the aqueous medium, that means H2O present. The base present in aqueous medium, it's produce the OH minus ion or it's remove OH minus. This is known as the base. Where is the another word? This is the strong. Strong means 100% dissociate or 100% ionized. For example, consider as the NaOH in presence of water, it's completely dissociate into Na plus and OH minus. For example, this is 100 molecule of NaOH converted into 100 Na plus and 100 OH minus. So NaOH completely dissociate into Na plus and OH minus. So this base is known as the strong base. You remember that in the periodic table alkali and alkaline metal present. This is the S group element. Whereas the alkali and alkaline metal hydroxide is the strong base. So alkali and alkaline earth metal hydroxide is strong base. This is the completely dissociate into its ion, cation and OH minus. So that way this is the strong base. How to find out the pH of the base? We know that the pH of acid. So pH of acid is equal to minus log 10 concentration of H plus. Because of in the acid H plus ion present, but in the base OH minus ion present. So OH minus ion present, its pH represented the POH. So POH is equal to minus log 10 concentration of the OH minus. So any base first calculate POH and any acid calculate directly pH. But in this case we find out the pH of strong base. But our value is the POH. How to find out the pH value? We know that the Kw is equal to concentration of H plus and OH minus. Kw is the dissociation constant of this water. So H2O dissociate into H plus and OH minus. So constant K is equal to H plus upon OH minus divided by H2O. Where this H2O and K multiply, because of the H2O is the constant value, it gives the H plus and OH minus. And this overall represent Kw is equal to H plus and OH minus. At room temperature, Kw value is 10 raised to minus 14 value. Room temperature Kw is 10 raised to minus 14 value. So this is the equilibrium, and in this case H plus and OH minus value is same. So this is the 10 raised to minus 7 and 10 raised to minus 7. In the converted into pH form, so this Kw is equal to 14, this is the 7 and this is the 7. So pKw is equal to pH plus POH. pKw is equal to 14 is equal to pH plus POH. For example, this POH value is 2. This POH value find out is 2. So 14 is equal to pH plus POH value is 2. So pH is equal to 12. So that way we find out the POH value. First POH value for the base, then 14 minus this value. This is the pH of the strong base. We know that in the pH scale 0, 7 and 14. This is the acid, between 7 to 14 base. So base value always greater than 7. Base value pH always greater than 7. This is the pH scale. So all 0 to 14 value present in the form of the pH value. For this base, pH always greater than 7. First example consider is the find out the pH of 0.1 molar NaOH. This NaOH is the strong base because of the Na present in this, the alkali metal. In alkali metal hydroxide always strong base. First NaOH dissociate into Na plus and OH minus. Its concentration given is the 0.1 molar. Always concentration given is the molar. Where given is the normality. So first normality convert it into molarity. Then this value put in this equation. So 0.1 molar NaOH. This is the 0.1 molar and this is also 0.1 molar. Because of the 1 mole of NaOH produce 1 mole of Na plus and 1 mole of the OH minus. So that value is the 0.1 molar. We know that the POH is equal to minus log 10 concentration of this OH minus. In this case, concentration of the OH minus is equal to 0.1. So minus log 10 0.1 concentration of the OH minus. In another case, 0.1 write the 10 minus 1. So minus log 10, this is the 10 raised to minus 1. This minus 1 and this minus 1, this is the plus 1. So plus 1 and log 10 value is 1. So POH is equal to this 1. But we find out that the pH of 0.1 molar NaOH. We know that the 14 is equal to pH plus POH. 14 is equal to pH plus this POH value is 1. So pH is equal to 30. And this pH value is greater than 7. So this is the base and this is the strong base. Because of the move towards the 7 to 14 side, means left to right, base is strong. In this side, weak base and near to 14, strong base. So this is the strong base. Next, find out the pH of 0.1 molar BaOH twice. This BaOH twice, this Ba present in the alkaline earth metal. So this is the BaOH twice dissociate into Ba plus 2 OH minus. Its value is 0.1 molar for the BaOH twice. This is the same value, but in this case 2 into 0.1 molar. Because of the BaOH twice is 1, Ba plus 2 also 1, but this is the multiplication with 2. So concentration multiply with 2. Then find out the pH. So POH is equal to minus log 10 OH minus. Minus log 10 OH minus value is 2 into 0.1 molar. So minus log 10, 2 into 10 raised to minus 1. This minus 1 and minus 1 plus 1 and log 10 1. Next is the log 2 minus log 2 and minus log 2 value is equal to 0.30. So this is the 0.30 POH. Then POH is equal to 0.70. Next, find out the pH of 0.1 molar BaOH twice. So pH plus POH is equal to 14. pH plus 0.70 is equal to 14. pH is equal to 14 minus 0.70. This is the 13.30. So this pH value is the 13.30. In this case, pH of the 0.1 molar NaOH is 13 and pH of 0.1 molar BaOH twice value is 13.30. Strong in 13.30 and this is the pH value 13. So this both have the strong base, but in the strength of the strong base is more because of the pH is 13.30 and this is the 13 value. Next is the, for example, consider as the XOH, XOH twice and XOH thrice. This X is the metal atom. Where is the XOH? So first is XOH dissociate into X plus and OH minus. Same as the XOH twice dissociate into X plus and 2OH minus. Same as XOH thrice convert it into X plus and 3OH minus. OH minus 1, 2OH minus and 3OH minus. What is the difference in this? The concentration value. For example, all three example consider as the concentration 0.1 molar. And we know that the POH is equal to minus log OH minus. For this, OH minus 1, 2OH minus and 3OH minus. So in this case, this value put same as this because of the 1 OH minus present. In this 2 into 0.1 molar because of the 2 OH minus, and this is the 3 into 0.1 molar because of the 3 OH minus present. So that way difference in this the concentration for the different hydroxide in this monohydroxide, dihydroxide and trihydroxide. Monohydroxide same value, dihydroxide multiply with 2 and trihydroxide multiply with 3. So that way we find out the POH value. Then find out the POH values. This value minus the 14. 14 minus this POH value gives the pH of this hydroxide. Next is the find out the pH of 10 raised to minus 8 molar NaOH. We start with the 10 raised to minus 8 molar NaOH. We start with the POH is equal to minus log OH minus concentration. We put the OH minus concentration as the 10 raised to minus 8 value because of this is the monohydroxide. For this, solve this equation. So POH value is equal to 8. But pH value is 6. This is not possible. For example, 10 raised to minus 8, POH is equal to minus log OH minus. This value minus log OH minus is equal to 10 raised to minus 8. This minus 8 and this minus, this is the plus and log 10 1. So POH value is equal to 8. And find out the pH value. So pH value is equal to 14 minus 8. This is the 6. But we know that this we know that the base present in this is 7 to 14. Between 7 to 14. That means the pH always greater than 7 value. But in this case, pH value present in this 6. So this is the wrong. So how to find out the pH value of 10 raised to minus 8 molar NaOH? We know that the 10 raised to minus 8 molar, that means the pH is equal to nearby 8. And near to 7, and 7 is the neutral. And its concentration value is 10 raised to minus 7. Because of this is the very dilute solution of this NaOH. So find out that the POH is equal to minus log 10 OH minus. But in this case 10 raised to minus 8 is very dilute solution. So very dilute solution, measure amount of this water present. Water present and water's concentration is 10 raised to minus 7. So this is the 10 raised to minus 8 plus water concentration 10 raised to minus 7. Put this total value in this equation. Minus log 10, 10 raised to minus 8 plus 10 raised to minus 7. Minus log 10, common value is 10 raised to minus 8. 1 plus 10. Minus log 10 into 10 raised to minus 8, and this is the 11 value. We know that the log 10 into 10 raised to minus 8, minus and minus plus 8. This is the minus log 10 into 11. So log 11 is 1.04 value. 8 minus 1.04 value, this is the 6.96 value. So POH is equal to 6.96. But we find out that the pH of this value, so pH is equal to 14 minus 6.96 value. This gives the 7.04 value. And we know that the pH greater than 7, it's known as the base. So this is the right way to find out the pH of 10 raised to minus 8 molar NaOH. Why put this value 10 raised to minus 7? Because of the 10 raised to minus 8 molar NaOH. This is the very dilute solution. In the dilute solution, measure amount of the water present. Water concentration is the 10 raised to minus 7. So dilute solution, we not negligible the 10 raised to minus 7 value. So that way we find out that the pH of this 10 raised to minus 8 molar NaOH is 7.04. The 10 raised to minus 6 molar NaOH is diluted by 100 times the pH of diluted bases. First of all, given value is this NaOH. So NaOH dissociate into Na plus and OH minus. So that means this is the monohydroxide. And this value is 10 raised to minus 6 molar. NaOH diluted by 100 times. Diluted by 100 times, so that divided by this 100, because of this concentration value is decreased. So this gives the 10 raised to minus 8 molar. So NaOH value is 10 raised to minus 8 molar. In the earlier we discussed on the pH of the 10 raised to minus 8 molar base. So find out the 10 raised to minus 8 molar plus 10 raised to minus 7 molar. Because of this is the very dilute solution and its pH value is 7.04. This is the pH greater than 7. So that way we find out the 10 raised to minus 6 molar NaOH diluted by 100 times. The pH of diluted base is 7.04. To find out the pH of 10 raised to minus 7 molar NaOH. In the see that the 10 raised to minus 7 molar. We know that the concentration of the 10 raised to minus 7, that means this is the neutral. But in this case, say that the 10 raised to minus 7 molar base means NaOH. How to find out this value? For example, simply POH is equal to minus log 10 OH minus. This is the NaOH, so monohydroxide, so its same value as this. Minus log 10 raised to minus 7. This minus 7 and plus 7 is 7. So POH is equal to 7 value and pH is equal to 14 minus 7. So this is the 7 value. So pH is equal to 7, that means this is the neutral. But in this case says that the pH of 10 raised to minus 7 molar NaOH present. How to find out the pH of this 10 raised to minus 7 molar NaOH? So first NaOH dissociate into Na plus and OH minus. 10 raised to minus 7 molar, same as the 10 raised to minus 7 and 10 raised to minus 7 molar. And in this case, 10 raised to minus 7, same as this neutral or same as this H2O concentration. But we know that we don't know that the exactly value of the H2O. This is the 10 raised to minus 7, this is the less than 10 raised to minus 7 or greater than 10 raised to minus 7. So this concentration consider as the X value. So H2O, H plus and OH minus. This is the X concentration, X and X concentration. This X and this is the 10 raised to minus 7. So total OH minus concentration is X plus 10 raised to minus 7. X, this is the X and this OH minus value is X plus 10 raised to minus 7. Because of the NaOH solution made with the aqueous solution. Aqueous means H2O present. So H plus value is X and OH minus value is X plus 10 raised to minus 7. And we know that the Kw is equal to concentration of the H plus and concentration of this OH minus. So this is the X and this is the X plus 10 raised to minus 7 value. Solve this 2 bracket x square plus 10 raised to minus 7x. X square plus 10 raised to minus 7x. This is the K. The X and concentration of X plus 10 raised to minus 7. Solve this 2 bracket x square plus 7 10 raised to minus 7x and Kw value is 10 raised to minus 14. So x square plus 10 raised to minus 7x minus 10 raised to minus 14 is equal to 0. Solve this equation and find the value of this x. Plus 10 raised to minus x minus 10 raised to minus 14 is equal to 0. So that way minus b plus or minus under root b square minus 4ac divided by 2a. Remember this equation. Whereas what is the value of the a? A value is this is the stoichiometric 1. B is equal to 10 raised to minus 7 plus 10 raised to minus 7 and C is equal to minus 10 raised to minus 14. Put this value in this equation and solve this. So x is equal to under root 5 minus 1 divided by 2 into 10 raised to minus 7 value. That way we find out the x value, but we find out the OH minus value. OH minus value is equal to x plus 10 raised to minus 7. Put this value in this equation, 0.618 into 10 raised to minus 7 plus 10 raised to minus 7. Common value is 10 raised to minus 7 and this is the 0.618 plus 1. So 10 raised to minus 7 multiplied with 1.681. This is the concentration of this OH minus. Whereas put this value in the POH is equal to minus log 10 OH minus. Minus log 10 OH minus value is 1.618 into 10 raised to minus 7 value. This is the minus 7 and minus plus 7, 7 minus log 1.618 value. So that way P618, 7 minus 0.208. This value is the 6.79 and pH is equal to 14 minus 6.79. So this value is given the 7.21 pH value. So that way pH of 10 raised to minus 7 molar NaOH is 7.21. In the next lecture we discuss on the pH of mixture. In the mixture acid and base present. How to find out the pH of this mixture. Thank you.